Hello everybody, I'm jiaozai, and welcome back. And here's an item from the field of combinatorics on counting. Again, credits to the Art of Problem Solving community for this item. The question is very short. How many 5-digit numbers have a digit sum of 8? As usual, pause this item if you want to give this item a try. And if you're done, let us dive into the solution. So let's start by a representation on the 5-digit number. So let the 5-digit number be A, B, C, D, E. Now usually if there is a line above a string of characters, it is to be read as digits and not the product. Now suppose there isn't the line above A, B, C, D, E. If there is no line above, then one might think that the A, B, C, D, E there is a product. So it's like A times B times C times D times E. But if there's a bar at the top of the A, B, C, D, E, then by convention it is to be read as a 5-digit number. So since that's the 5-digit number, the following equation must hold: A plus B plus C plus D plus E should equal 8, since the digit sum should be 8. Now note that A must be a positive integer, since if A is 0, then the first digit of the 5-digit number would be 0, and that would not make sense. So A must be a positive integer. But for the rest of the digits, it can be 0, so it can be any digit from 0 to 9, so we can say that B, C, D, and E are non-negative integers. Now, the main concept to be used here is the concept of balls and urns, or stars and bars. But to satisfy the condition for balls and urns or stars and bars, A, B, C, D, and E here should be non-negative integers. But here we have A to be a positive integer, so we must deal with that first. So let's have the representation of A prime. Now since we have A is greater than or equal to 1, we can let A prime to be 1 less than A. Now if we have A prime to be 1 less than A, then we can say that A prime is greater than or equal to 0. Now if A prime is greater than or equal to 0, we can conclude that A prime is a non-negative integer. So since we have the representation A prime equals A minus 1, so we have A equals A prime plus 1. So we substitute A as A prime plus 1 for here, and then we're going to end up with this equation here. So A prime plus B plus C plus D plus E equals 7. Now, note how the right-hand side of the expression is 7. Therefore, the maximum of any of these variables should be a 7. Since they're all non-negative integers, none of these 5 can be 8s. Because if one of them was an 8, then there must be at least one number out of these 5 that is a negative number. So we can conclude that all of these numbers should be numbers from 0 to 7. Sorry, integers from 0 to 7. So we don't have any problems here. Now, since we have satisfied the condition that we must have a sum of non-negative integers now equaling to some integer on the right hand side, we can finally use stars and bars or balls and urns to help us with this item. Now since there are no additional restrictions, since we know that the digits are only from 0 to 7, and there are no other restrictions posed on the 5 variables, we can finally solve this item via stars and bars or balls and urns. Now from the equation above, all we have to do is use the formula for stars and bars and balls and urns. Now if you're not familiar with the formula, this is how I solve or memorize the formula. Whatever is the number on the right plus the number of plus signs. So since there are 5 variables, I would need 4 plus signs to sum up the 5. So I have 7 plus 4. And then I'll choose the number of plus signs. So 7 plus 4, choose 4. And this is indeed the same, since 7 plus 4 is 11, and 7 plus 5 plus 1, sorry, 7 plus 5 minus 1 here is 11, and then 5 minus 1 here equals 4. So these two are equivalent. So whatever method you like to use, you're going to end up with the binomial coefficient 11 choose 4. So just evaluate 11 choose 4, and you're going to get the answer of 330. And this will be our final answer.